Hi there. Are we live? It says live 8 seconds. I still haven't seen. There we are. All right, 20 seconds. Great. We're here. Yeah. Uh, Hi, everyone. Been thinking about the project. What are we going to do next? And here, let me put the stream out first so everyone can find the link. I don't know if anyone saw yesterday's stream. I haven't checked in, but just a second here. Since stream is healthy. Get shareable link. Here we go. Oh, I have to open the link first so we get a real YouTube link. There we go. That should work. Oh. I'm not logged in as myself. What a silly mistake to make. Let's try this on my own channel. Here we need to copy that. Don't want to have to type those emojis. Typing emojis is terrible. All right. This software doesn't work very well, does it? There we go. This is my channel. Oh no. Okay, here we go. Now I can publish my channel and give it a clever tagline. Like Sunkworks, the name of this. Here we go. Perfect. Hopefully that actually worked. I can't really tell if channels are working or not. I thought I had published my other channel, but it didn't seem like it was getting published actually. Okay. So let's recap what we did yesterday. Trying to take a backup of my laptop, which I want to do as quickly as possible. So, not over Wi-Fi. And it so happens that I have one Ethernet cable here at my desk. It's plugged into my workstation, which is also a Kubernetes node. And it happens to be the Kubernetes node that I use for a lot of fun stuff that I do. So some of this stuff came back and some of it did not. This one was just 404. This one, okay. So we're going to assess the damage here. We're going to talk, we're going to call back to a previous episode. I can't remember exactly which episode, where we talked about building websites. And we're going to make a connection that we have failed to make before. So about how we can make um, how we can make a more efficient server where we don't need to call functions. So basically, how we can host static content. I've heard a lot of people using CDN services like Akamai or Fastly, um, and uh, that's a great way to scale when you really need to scale. But just in terms of making your site more efficient, if you don't actually have, like for example, this is a Jekyll blog here, and I don't remember exactly how I can prove that. It is actually running a Ruby process. Does anyone know? Can you call like version endpoint or something and see Ruby? Well, take my word for it. It is running a Ruby process, and if we look at the Kubernetes cluster where heavy staging where it's deployed, the blog app, it's deployed like a regular Ruby server app, which is really absurd. And I knew it was absurd when I did it, but I really wanted to use build pack because this was to test Heavy Workflow, the lazy smart pass. Um, so it made more sense to use a build pack, and once you're using a build pack, you might as well go all in. Here, I'll show you the deployment of this before we go to the Kubernetes cluster. Here is our blog site. We've got a copy of the ingress here in case we need it, I guess. I don't know, why did I save this? Or I'm pretty sure this is obsolete config. Yeah, that doesn't work, but this one works. And there's also teamhefi.info, which does not work right now because these sites are deployed in different ways. So there is something to be said for the build pack approach, but it's tremendously wasteful is what I'm trying to say, because it's really just static content. There are no functions we can call besides that 404 page, which I guess is technically a function. But if we are aware of things like that, if we use a CMS, I guess how hard can it be? You know, I mean, just to set up a static website. I feel like I avoid doing that way more often than I just do it. I could just do it. It wouldn't be such a big deal, right? Except every time I do it, it comes out a little bit different. And it seems like after I've done this 4 or 5 times, that it might have been a mistake to do this at all. And that's kind of where you go when you start your microservices journey in a small, not experienced developer shop. You wind up in that place before you get to the city on the hill. So that's what this blog was supposed to be about. What we're going to do is just take some static sites that are a little bit over complicated in the way they're deployed. Well, not the way they're deployed, but the way they actually are deployed at runtime. So I'll show you what I mean now. If we look at the proc file here, you see bundle exec Jekyll serve. Okay, keep that command in mind. So, one of the challenges we may face is that some of the services, as we have already seen, some of the services did not come back after yesterday's backup, and we may need to do some intervening in order to get those services back online, just so we can see what they are before we shut them down again. We're going to shut them down because, like I said, I need to take the backup of this laptop. And I only have one Ethernet cable for this desk, so want it to be fast, so. So I'm not going to do it over Wi-Fi. All right, let's see what's going on. I will zoom in a little bit here for the folks who are on a laptop or don't have a screen that's this big. This big. So I'm probably should back up and explain how I know that something is wrong. This is what when I speak about situational awareness, this is what I mean. Typically, I am looking for my monitoring dashboard so that I can show you, yeah, my monitoring dashboard. Here, we're going to do some Minecraft later on stream, but here. So we know some things are wrong here because these alerts have been firing since I left my desk yesterday. And it's not just one or two things that are wrong here, but the cluster's still online and all the nodes are ready. So what happened? What happened? Let's find out. I have this alias what's wrong, and there's L what's wrong also, oh, and N what's wrong. I forgot about that one. What is N what's wrong? Oh, namespace. Namespace what's wrong. Okay, so what's wrong across the management cluster? We see lots of crash loop back off. So I'm wearing my vCluster shirt today, and this is, I honestly don't know who's the culprit here. I have a suspicion, I have a guess that I have an idea what was wrong. I think it's this CorDNS here. And I'm going to point the finger at vCluster because I don't know any better. I don't know who actually is responsible for installing CorDNS and the manifests. It might actually be K3S. So it could be K3S issue. Could be we've chosen the wrong version of K3S for our host system. I think that it's not the Docker node. I think that's not actually the problem. For those of you that don't know, so these two machines run containerd. Here, let's see. We have lots of RAM in these machines now, so there's plenty of RAM. So if it weren't for stateful dependencies that we have on a particular node, we should be able to shut this node off without any problem. So the goal here, we're not going to get to all this today. We're going to talk through a little bit of this, but the goal here is to turn our deployments all as stateful and diamond perfect as possible. So I have some different kinds of deployments that I do for websites, and some of them are better or worse, apparently. Some of them are live sites, like this is a JavaScript site. This is a Ruby site. And some of them are just rendered content that we can host from Nginx, assuming that we can get to the back end. There might be a back end service that even the static content accesses, or that the users access through the static content. But there's almost certainly a static part that we're going to want to host, and we need to have a standard way to do that. And I'm not totally sold on the spin method yet, although I think that might be here. Yeah, that one's down too. Well, all right, let's see. If we fix CorDNS on all these clusters, we'll just start coming back. I think what's happening here is every time I reboot all the nodes, it results in all of the vClusters restarting, and when CorDNS restarts, for some reason it takes a definition from static manifests. I believe that's how Kubernetes works. I don't know how I can override those static manifests, but one day I think we'll figure that out. But I do know that I can patch them at runtime, and then Flux will patch them. Will ensure as soon as Flux can reach the internet, it can actually see the problem. The secondary problem is that when Flux restarts, all of this stuff happening at the same time, CorDNS going down and Flux restarting, results in we do not have the ability to rectify our config, because Flux is by default configured to keep things in memory. So the solution here is actually not less statefulness, it's more statefulness. We need to have a persistent volume for Flux so that when the cluster goes down, the GitOps cache, the source cache, does not go away, because we should be able to fix, Flux should be able to fix this CorDNS issue. There is a patch already in Flux that in the Git repository that if Flux could only fetch it, it would be able to fix CorDNS right here. But so there's our chicken and the egg. So so on the host cluster, CorDNS is fine. That note is why I point the finger at vCluster, because my vClusters have this problem, but nothing else does right now. So we're going to try an alternative to vCluster later that's called Cosmotron that I haven't had a chance to plug in yet, but we're going to try it out. So need to connect to a vCluster. Can I switch? Let's see. vCluster connect. Let's just connect to that one first. Okay. Oh. So CorDNS is actually fine on this one. That's interesting. So I guess Hefe stage is the only cluster that's not affected for whatever reason. Maybe we fixed it, or maybe we fixed it on stream yesterday when I wasn't paying attention. Let's try a different one. I know this one is not healthy, and I think this one is also not healthy. Yeah, okay, crash loop back off. And if we delete the pod, we'll see it does not help. You can't do that. I don't want to lose what's in my clipboard, but I want to show that if we delete this pod, it does not help at all. Yeah, because the definition actually says let's look at the definition here. So I suspect how this happens is this image, CorDNS does not refer to a particular image version, which we saw in the BotCube office hours, or maybe we did not see. It's been lost in our mess of errors now. Where is it here? Certainly, there's one green error that shows up, and it's don't use the latest tag. I really like that one. Here we go. The latest tag, yeah, this one should be avoided, and the reason it should be avoided is because it can change, and your manifests probably need to change as well. if it changes. This is also the reason why we don't typically see people using Flux image update automation in production, because you don't typically want the image to be deployed without the matching config. And this is a problem that Flux OCI repository solves. Just an aside. We'll come back to that in a future episode, but so what's missing here is, here in our security context, we do not have privilege escalation allowed, and we have dropped all capabilities, which is a problem for us because we should be listening. Well, our config says we should be listening on port 53. Here it's got us on 1053. Maybe if we listened on 1053, the problem would go away. But the secondary problem is that we don't populate that initial config. So the config itself is out of sync. There's somehow that happened. And I blame vCluster, but it might also be K3S, or it could be the combination of the two. Or it could be my own stupid fault. I'm not really sure here. But I know that I have introduced some custom config, so it is distinctly possible that it's my fault that we're listening on port 53 when we shouldn't be. But we do want to listen on port 53. We have been listening on port 53, and we should be able to continue going listening on port 53. So how do we patch this? Well, if Flux was doing it, it would come from here, and so we're going to take this as well. Kubectl patch. Let's see, can I... Now the problem here is I cannot... Wait a minute. That was it. I cannot just run commands against the cluster right now because OIDC is down. DEX is down. So for me to get DEX back online, I think we need to fix this core DNS deployment first. And we have to do that SSH'd into the cluster's master node so that we can bootleg ourselves into one of these vClusters. So, alright, so I need this patch command. Kubectl patch. Here, we'll get this command. And instead of using a patch file, we are going to use system standard input. Oh, it doesn't work like that, I guess. Can you patch from standard input? You probably have to cat. Like this. Is that going to work? No. You don't cat like that. Wait a minute. Just want that. Unable to read patch file. No. I guess you can just give it a patch directly then, like this. So no, that's not, there's no way that's going to work. Okay, that worked. And core DNS is back online. Okay, so let's try the same thing for Mu cluster as well. And we'll do that one more time for the staging cluster. What was that cluster called? Howard Mumbu staging. So we have nested V clusters. So once, let's see if we can get our power. We're going to run out of power before this stream is over, unless we get, there we go. All right, so things are looking better now. We don't have lots wrong on this cluster, at least. Still see some things. Okay. Just going to delete these error pods because there's nothing configured to go and delete them. They're here for me to observe and see that something went wrong. Okay, so here, this is what we want to see. We want to see Harbor is coming back online. And that's going to let us... So let me explain what's going on here. All right, we still have a few core DNSs down, but that's okay. We can come back and clean that up from outside once. We should probably see this is working now, right? Yeah, Dex is coming back online, so we can actually authenticate, and we can see all these websites that as soon as Harbor comes back, all these websites that have a dependency on Harbor on container registry will not fail anymore. So it's a little sneaky here because we have two dependencies on the container registry, and I'm not sure, well, I guess the reason is that the node local cache actually has the images to run already. So they've been pulled, and their pull policy is if not present. So there is no problem launching the container from Kubernetes perspective, but the container is not the end of the story. We're using OCI as storage in the container. So we are actually loading the content at runtime. And there are a couple of places in here where we have things set up to kick us off if we're not able to, if we need to get the latest version of the content, if there's a new version that comes in. So we use different strategies to do that. And they don't all respond well to failure. So one of the goals here is to come to a better place where we don't have to run a Ruby process. Maybe we can use Spin. I think Spin is a good approach because we can definitely scale Spin, but Spin will also limit some things that we'd like we can't use Ruby if we're using Spin for reasons that we've explored in other topic talks. But I think that solutions will come. We just need to get incrementally better. That's what we want to do. So I can switch between clusters now, I think, right? Yeah, okay. Harbor Job Service is still in crash loop back off. But Harbor Core is up. So that probably means this will be up as soon as it gets restarted. Cool. Yeah, Harbor's kind of a pain to run, but Harbor is online, so I guess the point I made the last time was that you want to think carefully if you want to run your own image registry. We want to run it here because we actually have to cope with a bandwidth limit. We're only allowed 1 terabyte a month from Comcast. So we actually, if we want to do iterative development and we want to do it fast with lots of iteration, where we build lots of images and sometimes the images might be large, then we have to have a local plan that we can use. So all right, we're down to 8. There's only 8 things. So let's look at it from that perspective here. Can definitely tail scale. Yes, tail scale is online. That's cool. Workflow docs, CubePod not ready. Alright, so this cluster is fine. This cluster is fine. Where's workflow docs not ready? Looks like these came back. Okay, so these did eventually come up. Well, not that one. Okay, they did. So there's some health checking set up, so they restart themselves until they come up. And when they restart, they try to fetch the content. And they don't actually have a local copy, so there's no possibility that they'll serve up some stale content because fetch fails. But there is always the possibility that they don't get restarted on time because the signal never arrives that there's a new image. I don't know, we can take different approaches to try to solve this, but we can see some of these alerts are dropping off again here. Okay, so cluster 01, cluster 03, Limno Central, and Botcube Demo all have the problem still. So they fail because they actually need Core DNS to be online in order to reach Harbor, even though their image is downloaded. So I think that's not a very good strategy. I think the the spin official strategy. This is not spin official. It says Wasenblog Bart, but I've used my own methods to build this Kubernetes installation. I built it a little while before they published the Kubernetes plugin for spin. It's probably much better than what I did, but I did a similar thing in there where it's fetching the WebAssembly modules at runtime, and that can fail. So probably you don't want to do that. And probably we should go back and update everywhere we've done that to try not to do that anymore. So let's see. Yeah, so here. Looks like Bart stage is online. Okay, so this is our Bartholomew blog example. And I guess what I'm trying to say is I think that all things being equal, we should probably get into a habit of just rendering content out to HTML and storing it and deploying that with whatever the lightest weight thing is to deploy. So if that's the static content module, then let that be it. But rather than deploying Bartholomew at runtime, rather than deploying Jekyll at runtime, if we don't actually need it for any dynamic content purpose, we should just leave that stuff up to JavaScript, right? If we need to detect the user's time zone, or if we need to set a cookie, we're going to do all that stuff in JavaScript on the browser, most likely. I think. I don't know. I don't want to be prescriptive about that. That turns people off sometimes. But clearly we have an issue here. We have more than one issue. That these things need some tender love and care once in a while that we probably don't want to have to provide. So we should adopt a different strategy. Yeah, alright, so all our sites are online now. So that one is not a thing here, I guess. That's actually a live response. All these things are online. Okay, so we are going to shut that node down like we said we were going to yesterday after we are still going to do that, but we want to see all these alerts go away first. It looks like at the top level everything is fine now, so I'm not sure how long it's going to take Prometheus to catch up. Right, we can look at the graph and we can see a lot of these things getting better in the last 15 minutes. We've got one still. Pretty sure that's online though. Yeah, it's online. Okay, cool. The alerts are all going away. This is our last one. That WASM blog that we just fixed. Okay, so let me go back to the show notes to make sure I'm actually going to do everything that I promised I would do here. Yesterday we broke a bunch of stuff. Today we're going to survey the damage and put it back. This all in service of backups. So yeah. So now if we shut the node down, we should see some of these things go back down, and most of them probably won't come back up because the Happy Staging cluster itself, a stateful entity, is pinned to this particular node. So we know a lot of this stuff is not going to come back until the node comes back. And that's our own damn fault. Most of those things don't really have a Docker dependency, so there's no good reason for them to be pinned to that node unless they have a stateful component. And most of them don't have a stateful component other than the Kubernetes cluster itself that runs them. So it feels like we've made a bunch of compounding mistakes to get to where we are, and we need to start unwinding them. That's my impression here, my intuition. Yeah, we still have one alert firing. That's what it says. I guess this says that it has been in crash loop back off within the last 5 minutes. So that's not going to go away until 5 minutes go by. We might already have... There. Alright. Alerts are all done now. Great. An alert manager is going to take a minute to catch up. Okay. So we said we're going to drain that node. Ignore daemon sets. Delete empty dir data. I guess you also have to cordon it, right? K cordon. Already cordoned. So question is the Moo cluster pinned to that node, or can the Moo cluster run somewhere else? Or does the Moo cluster depend on the stateful volume that lives on that node? I think it does. Alright, one node scheduled, disabling, scheduling disabled. Yeah, so Harbor is pending because I see. So that is going to be a problem for all of those things. So unless they ran somewhere else and already fetched their content, then we might be in luck. But all right, what else? What else are we losing? We lose the entire Howard Mombu space cluster? I think so. Yeah, he is not. He is not online. So a lot of these are down again. That's okay. It's okay. We're not going to do the backup on stream, but we are now. We've at least taken a catalog of all the things we'll lose if this node doesn't come back online. And we've talked a little bit more about the how hard can it be to host a website problem? How hard can it be? Well, it can be as hard as you want to make it. That's that's the answer. I have done this to myself more than anything. Here, let's put these all back. Yeah, all these are down right now. So tune in next time for the exciting conclusion, which I guess there's no exciting conclusion now. There's no cliffhanger. Everything. Well, they'll come back. Probably not on the stream, but maybe we'll do another stream where we bring it back, that one node. And I would really like to not have these stateful dependencies. I would like to have a distributed file system again across the 3 nodes, such that if one of the nodes goes down, the other 2 can pick up the slack, because there's 3 copies of everything, and if the second node goes down, then it's really just a problem that we don't have enough slack capacity to populate a 3rd node. That's why you always want to have 5 nodes. Who else has ever built a distributed file system? It's lots of fun for heavy, for virtual machine sized capacity. It's lots of fun. All right, so it's cordoned. It's been manually cordoned. It's drained. It's not coming back on its own. I'm going to shut it down. And we'll save some power for a little while, and I'll borrow its Ethernet cable so that I can back up my laptop. That's what I'm going to do. Cool. All right, I think we pretty much covered it this time. Thanks for tuning in. I don't think anyone is tuning in, but thanks for anyone who even thought of tuning in. It's been fun. See you again next time.